Hello everyone, welcome to Prince on Air, and today we are going to discuss about the remaining questions of back exercise of chapter 1 of class 11th, that is some basic concepts of chemistry. Okay, so here we will discuss about the solutions of quiz 1 also. Okay, so be with us, and here we will discuss about the quiz 1 solutions. Okay, and each that question we will discuss here. Okay, so now let's start it is a fourth video of solutions of back exercise. Okay, and here we will discuss about the quiz of solutions, means solutions of quiz. Sorry. Okay, so now here first question of this video is, how many significant figures should be present in the answer of the following? Okay, so that we have discussed in the significant figure. Okay, the topic of significant figure we have discussed there in case of significant for multiplication and division, and for addition and subtractions also. Okay, so here it is multiplication and division. So in this case we have to focus on the number which is least precise. Okay, so least precise means you can say which is having less significant figure. Okay, so here the significant figure in this number is 4, in this number it is 5, in this number it is 3, in this number it is 4. So just we have to focus on the minimum significant figure, and that minimum significant figure will be equals to the answer. So here it will be 3. Okay, now in this case once again multiplication is there, so in this case we have to focus on the minimum significant figure. Okay, so the number having minimum significant figure, is it? No, because it is an exact number. Okay, exact number, and exact number is having infinite significant figure. Okay, so answer will comes out to be 4 here. Next, in this case, see, for addition and subtraction we have to focus on the, you can see that number having less number of decimal places, but all are having four digits. Okay, 4 decimal places, so that will be equal to 4. Clear? So next question is, use the data given in the following table to calculate the molar mass of naturally occurring argon. In this case we have to calculate the molar mass, means average molar mass or average atomic mass of argon. Okay, and abundance is also given to you, and atomic mass of, you can say, isotopic molar mass is also given to you. So how we can calculate it? Firstly I will provide you the way how to calculate this, and then afterwards we have to do that calculation. At last I will give you that calculation solution. Okay, so just try to yourself. Firstly I will give you that answer, or you can say way to solve this question. Do that multiplication. Okay, so it will be 35.96755 into 0.337 plus 37.9672 into 0.063 plus 39.9624 into 99.600 by 100. So only this calculation you have to do, and through that calculation you can get the average atomic mass. Okay, so average, all of you know that this is the atomic mass of this isotope, and if you will multiply its abundance, okay, you will get the total amount of the given argon 36 in a nature. Okay, similarly for this. So if you will add all these components, all total mass of that components, and that will come out to be in the abundance is in percentage, no? So if you will divide it by 100, you will get the average. Okay, average atomic mass of argon here. Okay, so just do that calculation, try to do that calculation, and then if you will multiply these two values, you will get 0.1212. Okay, and then you have to multiply these two values, you will get 0.02391, and then multiply these two values, you will get 390, or approximately. I will give you that answer directly. Okay, you can do that calculation. I will give you that answer directly, and it should be comes out to be 0.1212 plus 0.02391 plus 39080.25 upon 100. So it will comes out to be 39.945. Okay, approximately that answer will come. Clear? Gram per mole. Clear? Only that calculation you have to do yourself. Okay. Next question. Calculate the number of atoms in each of the following. Okay, so that is the interesting question here. Firstly, for 52 moles of helium. See, 1 mole of any element here, helium will contain 6.02 into 10 raised power 23 atoms of helium. Clear? And 5 moles, 52 moles will contain that will be 52 into 6.02 into 10 raised power 23. Just you have to multiply this. If I am considering approximately 6, so 52 multiplied by 6, so 312 into 10 raised power 23, or approximately you can say 3.12 into 10 raised power 25 atoms of helium. Okay, so that will be the answer of first question. Clear? So next, 52 units of helium that we have to do. See, 1 unit of, you can say that 1 atom of helium is having 4 units of mass. Okay, of helium. Clear? So you can say 4 units combined to form 1 atom of helium. Okay, 1 unit will give you 1 upon 4 atom, and we are having 52 units, so 52 units will give you 52 upon 4. It will comes out to be 13 atoms of helium. Okay, so answer is 13 atoms of helium. Clear? Clear done? Next one. Next one is 52 gram of helium. So all of you know that firstly we have to calculate the mass of the helium in terms of gram. Okay, so try to do that question. If you will have 4 gram of helium, okay, gram molar mass, you will contain 1 mole of helium, means 6.02 into 10 raised power 23 atoms of helium. Okay, clear? Means 4 gram of helium will contain 6.02 into 10 raised power 23 atoms of helium. Okay, 1 gram of helium will contain 6.02 into 10 raised power 23 atoms of helium. Okay, now we are having 52 grams, so 52 grams will contain 52 into 6.02, wait, here we have to divide by 4 also. 4 gram of helium will contain 6.02 into 10 raised power 23 atoms of helium. 1 gram will contain 6.02 into 10 raised power 23 upon 4. Okay. So, for 52, if we are having value for 1 gram, then for 52 you have to just multiply it by 52. So, it will comes out to be, so solve this value, it will comes out to be 13, 13 into 6, 13 into 6, 8, 98 into 10 raised power 23 approximately. Check it once. Is that question is right now? 1 3, okay. Okay, it will comes out to be 78. 13 6 8 1 6 7. Okay, so 78 into 10 raised power 23. So it will be 7.8 into 10 raised power 24 atoms of helium. Okay, clear? Clear now? Now let's move to next question. Next is, a welding fuel gas contains carbon and hydrogen only. Burning a small sample of it in oxygen gives 3.38 gram carbon dioxide and 0.690 gram of water. No other products, means without any that carbon dioxide and water, no other product was formed. Products, a volume of 10.0 liter measured at STP of the welding gas is found to weigh 11.6 gram. Calculate empirical and molar mass of gas, empirical formula, molar mass and molecular formula. Okay, so these three terms we have to calculate from this equation. Okay, so just listen carefully that question once again. A welding gas fuel contains carbon and hydrogen only. Okay, burning a small sample of oxygen gives you 3.38 gram of carbon dioxide. Okay, and 6.690 of water. Okay, so listen carefully. Here we all know that 44 gram is the molar mass of carbon dioxide. So 44 gram of carbon dioxide will contain how much amount of carbon? That will be 12 gram. Okay, 44 gram of carbon dioxide will contain 12 gram of carbon. Is it clear or not? So 1 gram of carbon dioxide will contain 12 upon 44 gram of carbon. Okay, we are having 3.38 gram carbon dioxide. So 3.38 gram of carbon dioxide will contain 12 upon 44 into 3.38. Okay, so just you have to solve this equation, you will get 0.9218. Okay, that amount you will get, means gram of carbon. Okay, next one. Similarly for water. Okay, 18 gram of water contains 2 gram of hydrogen. Okay, 1 gram of water will contain 2 upon 18 gram of hydrogen. We are having that water is 0.690 gram. 0.690 gram of water will contain 2 upon 18 into 0.690. So it will comes out to be 0.0767. Okay, that calculation I have done already first. Okay, I just telling you that calculation I have done myself, and just I am providing you that answer here. Okay, of hydrogen. Now we got the mass of carbon and mass of hydrogen. Just we have to add these masses. So in this way you will get 0.9218 plus 0.0767, and if you will add both this value you will get 0.9985 gram. Okay, so that is the total mass. Now you have to calculate their percentage abundance. So percentage of carbon will comes out to be 0.9218 upon 0.9985 into 100. Similarly, percentage of hydrogen 0.0767 upon 0.9985 into 100. Okay, so try to do that calculation to calculate the percentage of carbon and hydrogen. Try it. Okay, so the percentage of carbon will comes out to be 92.35. Okay, 92.35, and here the percentage of hydrogen will comes out to be 7.65. Okay, so now we got that mass. Similarly with that, in whenever we are calculating the empirical formula, we got only the percentage. Okay, so through that we are calculating the molecular empirical formula. So similarly that table we will make here: elements, carbon and hydrogen, their atomic masses, given masses. Okay, given masses first we can take. If the full sample is made up of 100 gram, so the mass of carbon will comes out to be 92.35 in gram. Okay, and that's of hydrogen, it will comes out to be 7.65. Now number of moles. So for carbon 92.35 upon 12, 7.65 upon 1. So both will comes out to be 7.65. Here also 7.65. So whole number ratio. Okay, whole number ratio will comes out to be, we have what we have to do there. We have to divide by that number which is lesser. Okay, smaller number. So both are almost same. So it will comes out to be 1. Okay, so the empirical formula. Empirical formula will comes out to be CH. Okay, so here empirical formula is CH. Clear? Now what we have to do here? Now we have to calculate the second part, that is molar mass of gas. What we have to calculate here? Molar mass of gas. So how we can calculate this? See, molar mass, how we can calculate? We have one more thing here, that is 10.0 liter of gas at STP. Okay, now we can do this. Okay, empirical formula we got, so we can write here it as in this way. Okay, now next one is a volume of 10.0 liter is the welding gas found to be weigh 11.6 gram. Means if you are having 10.0 liter of welding gas, it will contain 11.6 gram. Okay, 1 liter will contain 11.6 upon 10 liter, and 22.4 liter will contain 11.6 upon 10.0 into 22.4 gram. That 22.4 liter is equals to 1 mole. Okay, which is equals to gram molar mass, or you can say the molar mass. Okay, so in that way molar mass is equals to this value. So just you have to solve this value, you will get the molar mass of the given compound. So it will comes out to be 20, approximately 26. Okay, 26 gram. Now what we have to do, we have to calculate the molecular formula. So see, firstly for that we have to calculate value of n. N will comes out from molar mass upon empirical formula mass. Okay, so molar mass is 26, empirical formula mass for CH 12 plus 1, it will comes out to be 13. So it will be 13. If you are cutting this value, you will get 2. Okay, so n value is 2. Now we know that molecular formula is equals to n into empirical formula. Okay, so it will comes out to be 2 into CH means C2H2, that is ethyne. Okay, so first question was we have to calculate the empirical formula. Empirical formula is CH here. Okay, empirical formula is CH here. Okay, then we have to calculate the molar mass of gas. Molar mass 26 here, and then we have to calculate molecular formula. Molecular formula is C2H2. Okay, so that is the answer of this question. Next question is, calcium carbonate reacts with aqueous HCl according to the reaction. That reaction is given to you CaCO3 plus 2HCl. It will form CaCl2, CO2 and H2O. Okay. What mass of CaCO3 is required to react completely with 25 ml of 0.75 molar HCl? Okay, so that is the question here. So see that equation and try to do that question yourself. Firstly, you should write the equation once again. So equation is CaCO3 plus 2HCl, it will form CaCl2 plus CO2 plus H2O. Okay, so this thing you have to feel first. Here calcium carbonate react with aqueous HCl according to the following reaction. Okay, what mass of CaCO3 means what mass of CaCO3 is required? Here I am writing the question mark. Okay, to react completely the 25 ml of 0.75 molar HCl. Okay, that is given to you. Now we know that from the value, from this value 0.75 molar, what is the meaning of this? It means 0.75 moles of HCl in 1000 ml of solution. It means that, okay, 1000 ml of HCl solution, it will contain 0.75 moles of HCl. Okay, now here you can say that 1000 ml of HCl solution will contain 0.75 moles of HCl. Now how much mass of that HCl will be there in this particular case? That will be in 1 mole of HCl, it will comes out to be 1 plus 35.5 means 36.5. So for 1 mole HCl we are having 36.5 gram. For 0.75 moles it will comes out to be 0.75 into 36.5. Okay, so just do that calculation, and through that calculation you will get 24.375 gram. Okay, 24.375 gram, that amount. in 1000 ml. Okay, means in 1000 ml of HCl solution you will get 24.375 gram of HCl. Okay, clear? Now if 1000 ml of HCl is containing 24.375 gram, 1 ml will contain 24.375 upon 1000. Okay, how much amount is given to you, volume is given to you, that is 25 ml. So for 25 ml it will comes out to be 24.375 upon 1000 up into 25. Okay, so through that you will get the mass, actual mass which is present here. Okay, clear? So in this case you can calculate the value of mass present in this case. Okay, then now what we have to do here, from the equation you can see here we need only 1 mole of CaCO3, here it is of 2 mole. Now given mass we got, that given mass comes out to be approximately 0.6844 gram. Okay, clear? Now what we have to do, CaCO3 plus 2 HCl and it will form CaCl2 plus CO2 plus H2O. Clear? Okay, so now 2 moles of HCl requires how much amount of calcium carbonate? It will comes out to be, the molar mass of calcium carbonate comes out to be 100. Okay, approximately it will be 100. So can I erase this? Okay, so in this case 2 moles of HCl will comes out to be, if 1 mole is this much and 2 moles, it will comes out to be 73 gram. So 73 gram of HCl will require 100 gram of CaCO3. Okay, 1 gram of HCl will require 100 upon 73 gram of CaCO3. Okay, so we are having how much mass of the HCl here, that is 0.6844 gram. So it will comes out to be 100 upon 73 into 0.6844. So just solve this value, you will get the mass of calcium carbonate. It will comes out to be 0.938 gram. Okay, just I am seeing that calculation. That's just I want to say, I am just seeing the calculation to save that time. Okay, so that will be the answer here. Clear? Next is, chlorine is prepared in the laboratory by treating the manganese dioxide with aqueous hydrochloric acid according to the reaction. So 4 HCl with MnO2 will form 2H2O and MnCl2 and plus Cl2 also. How many grams of HCl react with 5 gram of manganese dioxide? The atomic mass of manganese is given to you, that is 55 units. So try to do that question yourself first. Firstly, you should write the equation once again. 4 HCl MnO2, it will form 2H2O plus MnCl2 plus Cl2. Okay, so that is the equation here. So try to do that question. What they are saying, how many grams of HCl react, means we have to calculate HCl with the 5 gram of manganese, 5 gram of manganese dioxide. Okay, so what will be the requirement of HCl in this case? Yes, done. So try that question now. 4 moles of HCl react with 1 mole of MnO2. Okay, clear? 1 mole of MnO2. So 1 mole of MnO2, you can say which thing we have to calculate, you have to put it at the right side, place it at the right side. Okay, so it will be 4 moles of HCl. Okay, so 1 mole of MnO2 react with 4 moles of HCl. In 1 mole, how much mass is there for MnO2? You have to calculate the molar mass here. So for molar mass MnO2, it is 55 plus 2 into 16. So 55 plus 32, it will be 87. So 87 gram of MnO2 react with HCl. HCl is 36.5 multiplied by 4, 73, 73 twos are 146. So 146 gram of HCl. Okay, 1 gram of MnO2 react with 146 gram upon 87 of HCl. Okay, clear? So for we are having 5 grams, so 5 gram we need 146 upon 87 into 5. You will get that value from here that you have to solve, and the answer will comes out to be 8.40 gram. Okay, so just you have to do that calculation only. Okay then. So next is we have to do that solutions of quiz 1. Okay, so here we have to do that solutions of quiz 1. First question was, which of the following is the most accurate? Firstly, I will provide the solution and little bit hint I will provide you, so you can do that that question. You can solve that question yourself. Okay, so just hint I will provide here. Which of the following is the most accurate measurement? Okay, those are which that value is having more significant figure, that will be considered as more accurate value. Here the significant figure will comes out to be, you can say in one way you can say it will be 1, or here it will be 2, here it will be 3, and here it will be 4. So the accurate value is this, D. Okay, next. Which of the following pairs illustrate the law of multiple proportion? See, in that case, just we have to see the that pairs which are having same type of composition. Okay, now, so answer will comes out to be here. Here that both are having different composition. Here it is same, lead and oxygen, lead and oxygen. Here it is different. Okay, hydrogen sulfur, sulfur oxygen, copper chloride and copper sulfate, not same. So answer will comes out to be B. Okay, just you have to see like in this way. Next is, now the next question is, what is the mass of carbon dioxide which contains the same number of molecules as are contained in 40 gram of oxygen? So see here, firstly we have to calculate the number of molecules of oxygen in 40 gram. Okay, so you know that very well. 32 gram is a molar mass of oxygen. It will contain 6.02 into 10 raised power 23 molecules of oxygen. 1 gram will contain 6.02 into 10 raised power 23 upon 32. Okay, that will be the value here. So that if we are considering this one is 6, 3, and don't solve this value. So here it should be 6.02 into 10 raised power 23 upon 32. Okay, so we are having 40 gram. So 40 gram, it will comes out to be 40 into 6.02 into 10 raised power 23 upon 32. That you know very well. Okay, so for on the table of 8 we will get 4, 5, 2, 3, 2.5, and it will comes out to be 7.5 into 10 raised power 23. Okay, clear? Now we got the number of molecules here. So we know that very well in case of carbon dioxide. So here that's 6.02 into 10 raised power 23 particle molecules of carbon dioxide weigh, that are carbon dioxide molar mass is 12 plus 32, 44 gram. So 44 gram is the weight of Avogadro's number of molecules of carbon dioxide. For one molecule it will comes out to be 44 upon 6.02 into 10 raised power 23. Okay, and we are having total number of molecules that are 7.5 into 10 raised power 23. So 44 upon 6.02 into 10 raised power 23, it will comes out to be 7.5 into 10 raised power 23. So solve that value here. How we can solve? On the table of 1.5. So it will comes out to be 4 and it will comes out to be 5. Okay, and 11. So 11. This one also will cut. So 55 gram will be the answer. Option B is the right one. Clear? Next question. The number of oxygen atoms present in 1 mole of oxygen gas. That is a so simple question here. Number of oxygen atoms they are asking you. Okay, not of molecules. So some student will do that this one, option A, but actually it's option B. Okay, it's option B here, because in 1 mole we know very well 6.02 into 10 raised power 23 molecules, because here it is oxygen molecules in gas. Okay, and one molecule is like in this way, and one molecule of oxygen will contain 2 atoms of oxygen. So just for to calculating the number of atoms, here we are having the number of molecules. To multiply it by 2, you will get 12.04 into 10 raised power 23. So we can write it as 1.204 into 10 raised power 24. Okay, so that will be the right answer. Next, what is the total number of electrons present in 1.6 gram of methane? So do it fast, very well. It is very interesting question. See, firstly we have to calculate the number of molecules of methane. So that methane is CH4, 12 plus 4, it will be 16. So 16 gram of methane will contain 6.02 into 10 raised power 23 molecules. Okay, 1 gram will contain 6.02 into 10 raised power 23 upon 16. For 1.6 gram it will be 6.02 into 10 raised power 23 upon 16 into 1.6. Point cut 10, cut this value, it will comes out to be 6.02 into 10 raised power 22. Okay, molecules. Now all of you know that one molecule of methane, how many number of electrons will be there? For carbon it will be 6, and for hydrogen it will be 4. Each hydrogen will contain 1. So it will comes out to be 10. So means one molecule of methane will contain 10 electrons. Okay, and these much number of molecules, okay, it will be 22. These much molecules of methane will contain how much number of electrons? Just multiply by 10. So it will comes out to be 6.02 into 10 raised power 23. So answer will be A here. Okay, answer will be A. Okay, so now what will be the mass of 100 atoms of hydrogen? 100 atoms of hydrogen. So try it. See, what will be the mass of 100 atoms of hydrogen? So firstly you have to calculate the mass of one atom, obviously. So how we can calculate the mass of one atom? See, 6.02 into 10 raised power 23 atoms, no, they are asking. Yeah, so atom will contain atoms are contained in 1 gram of hydrogen atoms. Okay, so one molecule mass will comes out to be 6.02 into 10 raised power 23. Okay, 1 upon 6.02 into 10 raised power 23 gram. Okay, so for 100 atoms we have to calculate the 100 atoms, no? For 100 atoms it will comes out to be 100 into 1 upon 6.02 into 10 raised power 23. So just solve this value. Okay, just solve this value. By solving this value, we will get answer, that is option D, because that is the only value in which power is getting negative here. Okay, so through that we can judge it. Clear? Next is, so total number of atoms present in 34 gram of ammonia is, total number of atoms present in 34 gram of ammonia. Ammonia's molecular mass is 23 plus 3. Okay, no, not 23. Nitrogen it is 14 and hydrogen it is 3, so 17. Okay, so for 17, clear. So number of atoms we have to calculate. 17 gram will contain 6.02 into 10 raised power 23 molecules of ammonia. Okay, 1 gram will contain 6.02 into 10 raised power 23 molecules okay, and 34 gram will contain 34 into 6.02 into 10 raised power 23 upon 17. It will comes out to be 2, and here the value will comes out to be 12.04 into 10 raised power 23 molecules of ammonia. Okay, clear. Now we got that value here, that is of number of molecules. Now we have to calculate the number of atoms also. So one molecule of ammonia contain how many number of atoms? 1 nitrogen, 3 hydrogen, it is 4. So the total number of atoms in 12.04 into 10 raised power 23 molecules, it will comes out to be 4 into 12.04 into 10 raised power 23. So it will comes out to be 48.16 into 10 raised power 23. So it will come, we can write it as 48 into 10 raised power 23. That will be the answer, option D. Okay, so for 7th, option D will be the right answer here. Next is, how many number of aluminium ions are present in the 0.051 gram of aluminium oxide? So see this, aluminium oxide is Al2O3. Okay, so one molecule will contain 2 Al3 positive ions. Okay, so how many number of aluminium ions present in 0.51 gram of aluminium oxide? So firstly you have to calculate the total number of aluminium oxide ions in a given component. So it will be, aluminium is having atomic number 13, so 27 gram of aluminium, 27, okay, 27, and then oxygen 16 threes are 48. So just you have to solve this value, and through that you will get the number molar mass. Let me check it once. 2 into 27, okay, aluminium has having 27 atomic mass, 3 into 16, okay, so it will be 54 plus 48, it will comes out to be 102, yes or no? Yeah, so it will be, if you are having 102 gram of Al2O3, it will contain 6.02 10 raised power 23 molecules of Al2CO3. 1 gram will contain same. Okay, how much amount is given to you? 6.02 into 10 raised power 23 upon 10 raised 102 into 0.051. So just you have to solve this value, and through that you will get the number of molecules of aluminium oxide. At last, to calculate the number of ions that we got that let's suppose we got that value n here, and for one molecule there is two ions of aluminium, and what we have to do here, the total number of ions will comes out to be 2n. So just you have to solve this value, okay, solve this value, and through that you will get the answer that's of option A. Okay, option A you will get, clear. So in this question, how many significant figures are present in 0.010100 into 10 to the power 3 means we have to calculate that, we have to tell that how many significant figures are there in this number. So that you can see here 0.010100 into 10 to the power 3. Okay, so it is that left digits we are not considering, left 0 we are not considering, so that will be considered because point is here, so right 0 will be considered here. So 1 2 3 4 5, so total 5 are there, that is also not considered here. So answer is B. Okay, answer is B here, clear. So next question is, which of the following has maximum number of molecules among the following? Okay, in these parts which one has a maximum number of molecules? So how we can calculate it? See, 44 gram of carbon dioxide will contain Avogadro's number of particles or molecules. In case of ozone, it is having 48 gram. So 48 gram is the molecular mass of ozone, so it is also will have Na. Hydrogen's 2 gram of hydrogen will contain Na, and 1 gram will contain Na upon 2, and 8 gram it will be 8 into Na upon 2 comes out to be 4 Na. Okay, Na is Avogadro's constant. Okay, sulfur 32 means 64, so 64 gram of it will also contain Na. So which one is having more? 4 Na for the case of hydrogen molecule. So answer is C here. Okay, clear. Okay, so thanks for watching this video, and once again I will say that keep studying, keep motivated, and stay at home, okay, and keep studying.